All right, thank you for watching this video. This video is going to be on transforming functions. So we're going to be transforming f of x into a new function, which we will call g of x. For this part one video, all of the functions I will be transforming will be f of x equals x. So we will be transforming the parent function of a linear function based on the given transformations to create a new function g of x. So let's get into it. Number one, the first step to all of these will be we need to write down f of x equals x. So translate up 3 units. So when I translate up 3 units, what does that mean? So the first thing is, let me pull out, should have a ton of spare copies of this somewhere. Here's one. Is when I look at my handy list of transformations, a vertical shift up or a translation up means that I am adding a positive value greater than 0, positive value to the entire function. So it just so happens that my entire function is just x. So I put parentheses around just x. Not necessary for this specific problem, I know, but it's a good habit to get in. And what we're going to do is we're going to translate it up 3 units. So plus 3, plus 3. All right, that's where, in the case of a vertical shift up or a translation up, k would be f of x plus k, f of x plus k. All right, so we're adding on k to the entire function. Well, now we're going to simplify, and this is now going to become g of x. And that equals, well, is there any point in having the parentheses there? No, there is not. So I just get x plus 3. And this is what it means by write a rule. So write a rule. This is the rule. G of x equals x plus 3. It's another way of saying write the function or the equation in function notation. This is the rule. I have written the rule for g of x after transforming f of x. Okay? So let's do the next one. Again, you start with f of x for all of these problems. Now I'm going to do an x-axis reflection. So an x-axis reflection is to multiply the entire function by a negative. So f of x equals parentheses around the x. So again, just a good habit. It just so happens that my whole function in this case is x, but I'm going to put parentheses around the entire function. So multiplied by a negative, multiplied by a negative. On this side, it's just going to become g of x because I've transformed it. On this side, I'm going to actually simplify algebraically. Okay, what is negative? What's a negative times a positive x? Oh, negative x. Done. That's it. All right, that is it. So the transform function is g of x equals negative x. All right, now we got f of x equals x. So we're going to go to the left 2 units. So if I look here, horizontal shift, left or right, so translation left or right, means that we're going to subtract a value to the inside, to the input directly. And if we want to go to the left, that means the value we are subtracting is less than 0. That means it's negative. So what that means is if we want to go left 2, this is actually going to be a negative 2. So we're going to have f of x, parentheses, equals. Now, this is where the parentheses come in handy. So I put parentheses around the variable, around the input. And I'm going to subtract a negative 2. And actually what I want to do, I want to make this, let's just make that red. Because what's special is this is the negative 2. So we're always subtracting And in this case, because we want to go to the left, we're subtracting a -2. So always subtracting, and we get a -2. So if we simplify, we will get g of x, because we are going to transform the function. We're going to shift it. So now we got our new function, g of x equals, well, this is just going to be x plus 2. That's it. A negative times a negative is a positive, so we get x plus 2. And the parentheses on the outside don't matter. They're not doing anything. Go. Let's do vertical shrink. So vertical shrink, we're going to have f of x equals x. So vertical shrink, any vertical shrink or stretch means that we're going to multiply the entire function by that value. And we're going to be multiplying, in this case, by a 1/2, which ends up making it a shrink. So we're going to have f of x, and we're going to multiply this entire function by 1/2. And the entire function in this case is just x, so we're going to multiply the entire function by x, or by 1/2. And our new function will be g of x equals 1/2 x. And that's it. All right, now we are going to start doing 2 transformations at a time. So now we're going to have f of x equals x still, but we're going to go up and to the right. So up means that if we're going to go up, we're going to add on a positive number. If we're going to go right, that means we're going to subtract a positive number. H is greater than 0. So that means that this is a +2 that we're going to subtract off. So we're going to have f of x. Oh, I always want to put my minus there. So we're subtracting a +2. And then we are adding a +3 to the whole function. So equals, I'm going to again put parentheses around my input, my variable. So x minus, so I get -2 and +3. So now I'm going to have g of x, and I'm going to drop these parentheses because they're not doing anything, and I get x minus 2 plus 3. Well, I need to simplify that more. I need to combine like terms. So g of x equals x plus 1. That would be the final answer. Final answer. So I shifted to the right 2, because that's a +2. I shifted to the right 2 because I'm subtracting a +2. And I shifted it up 3. I translated it up 3. All right. Then we got f of x. Maybe I'll got more room over here. Let's do f of x equals x. Horizontal shrink by 5 and translate up 2. So translate up 2 means we're going to add on 2 over here. We're going to add on 2 over here. And a horizontal, what is it? Horizontal shrink. Horizontal shrink means we're going to multiply the inside. We're going to multiply the inside. So we're going to multiply the input directly. So we're going to have f of, we're going to multiply the inside by a 2. X, but then we're also going to translate it up 2, so we're going to add on, or no. Oof, I messed up. Horizontal shrink by 5. I think I can change this to a 5. Yeah, that looks like a 5. Okay, and then we're going to translate it up to, my bad. So horizontal shrink by 5, we're multiplying the inside by a 5, and then we're adding 2 to the entire function on the outside. So this is going to equal, again, we're going to put parentheses around our input. So input, oof, messing up, I'm messing up, getting tired. So we're going to have 5x, and then we're going to add 2 to the entire thing. So add 2. All right. So we now have g of x. Is there any point in these parentheses? No, there is not. So we're just going to get 5x, and then we're just going to have plus 2. So that would be g of x, and that's done. So horizontal shrink on the inside by multiplying by 5, and then a vertical shift up or a translation up by 2. So adding to the whole function. All right, translate right. Okay, so first off, we got f of x equals x. Translate right to, so when we're going to the right, that means positive. So translate to the right means h is greater than 2, so we're going to subtract off positive 2. And then reflection in the x-axis. X-axis means we're going to multiply the entire function by a negative. So what have we got going? So what have we got going is f of x minus, let's actually put parenthesis over here, equals. So we are subtracting off a positive 2, and we're going to multiply the entire function by a negative. So we're going to multiply the entire function by a negative. On the inside of the function, we're subtracting 2 over here as well, subtracting a positive 2. All right. So this is going to change to be g of x. We need to distribute the negative. Negative times a positive x is a negative x, and a negative times a negative 2 is a positive 2. So there's g of x. We have transformed x. We have translated it 2 units to the right and reflected it about the x-axis. All right. Fun stuff. I got 3 more examples for this part 1 video. 3 more examples. I always think the part 2 video makes more sense because we're not doing the parent function. So please watch part 2 also. If not, only part 2, honestly. Translate, so we're still doing f of x equals x. So we're going to translate up 3 units and then vertically stretch by 2. So up 3 units means we're going to add 2, and a vertical stretch means we're going to multiply the entire function by 2. So we're going to add 2 to the entire function, and we're going to multiply the entire function by 2. So we're going to have f of x. We're going to multiply the entire thing. Oh, I'm sorry, up 3. So we're going to multiply the entire thing by 2, and we're going to add 3. Equals. Okay, well, what is the entire function? The entire function in this case is x. That's the entire original function. It's just x. So we're multiplying the entire original function x by 2 and then adding 3. Okay? So we've transformed f of x to now become g of x. And 2 times x is 2x, and then we just have plus 3. So there's g of x. Now things are going to get fun. Number 9 is where things start to get fun, and there's a really important word in there that I will highlight momentarily. So number 9. Again, we start with f of x equals x. Finish that off. Okay. Translate left 2 units and then, or translate left 2 units and vertically stretch by 4. Period. So that means we're going to do all of this stuff first. In the first sentence, we're going to do all of that first. So translate left 2 units and vertically stretch by 4. So left 2 units means this is going to be a negative because to the left means that h is less than 0, which means that's a negative 2. So we're going to have f of x minus, and then we're also going to vertically stretch it by 4, and that means multiplying the entire outside by 4. So this is what we have here. So we are subtracting on the inside a -2 because we're going to go to the left. We're going to go in the negative direction. And we're multiplying by 4 to vertically stretch it. All right, so this will equal. So I'm going to, over here, x minus, because this is all happening on the inside. So I circle my function. I circle my input, which in this case is the whole function. But what I'm specifically doing, I'm circling my input or putting parentheses around my input and subtracting -2. And then I'm multiplying the entire thing by 4. All right, multiplying the entire thing by 4. So what do we have here? We have a new function, which we will call g of x equals, okay, well, this would be 4 parentheses x plus 2, which means this will be 4x plus 8. Okay, now we're actually going to have to go another step because there's this then fancy word, then. So now we're going to do something next. So now what we're going to come around and do is we are actually, let's take this and restart the entire thing of g of x equals 4x plus 8. And we want to reflect this. We want to transform this new function into a whole new function. We want to transform it one more time. So reflect across the y-axis. So across the y-axis is just to the input. Now this is where it starts to make a whole lot more sense, I think, of if I want to do something just to the input, if I want to do it just to the input, then that means I need parentheses around the input. Are there any parentheses around the input, around the variable? There aren't. So I'm going to create them. I like that. There are parentheses around the input. We now can do something to the inside. So when I do something to the inside, which in this case, we're going to multiply the inside by negative. So g of negative x is going to equal 4 parentheses negative x plus 8. So we are multiplying just the variable, just the input by a negative. We are multiplying just the input by a negative, which is x. So we are now going to get a new function. I don't know, what do we want to call it? H of x? Let's call it h of x. Equals, okay, well, what's 4 times negative x? Oh, well, that's negative 4x. And then I just dropped the plus 8. So there is my final answer. So I transformed it a second time because of the word then. It told me to do a transformation first and then a second one. All right. Let's do that one more time. This one doesn't have a period, but it does have the word then in it. So we're going to do one thing first and then the second thing second. All right. So we're going to start off with f of x equals x. And it says translate down 2 units. So translate down 2 units means to subtract off 2 to the outside, to the whole function. Subtract off 2 to the whole function. So put parentheses around the whole function, subtract off 2. We now are going to have g of x equals x minus 2. So let's take that. G of x equals x minus 2. And now I want to horizontally stretch by 1/3. So now I want to horizontally stretch by 1/3. Well, a horizontal stretch happens on the inside. Horizontal happens on the inside. Do I have an inside? I do not have an inside. That's an issue. So I do not have variables around my input. So I need to put variables around my input. Because we're multiplying just the input. So we need to put parentheses around just the input. So we're going to have G, and we're going to multiply the inside by 1/3. And then multiply just the inside by 1/3. And we are left with a new function, just like last time, which we will call h of x in this case, equals, well, are the parentheses really necessary? No, I don't think they are. So it's just 1/3 x minus 2. Now in every other case, I've said in my other video about transformations so far that linear functions are a special case. Because when we do something specifically to the input, it really doesn't matter that much because there's nothing special happening to the input besides that new thing. It's not being squared like a quadratic. It's not taking the absolute value of the input like an absolute value function. It's not taking the square of it like a radical function. So a linear function, do the parentheses matter that much? Sometimes they do. Like up here, it mattered a little bit. Because I didn't make the 8 negative, I only made this negative. I didn't make the whole thing negative, only that. So what's important to remember, and this will happen a lot if you watch part 2, so please watch part 2 after this, of if it's happening to the outside, put parentheses around the whole function, and then do whatever it is to the outside of those parentheses. If it's happening on the inside, put parentheses around the variable and do whatever's happening on the inside to the inside of the parentheses to the variable. I hope this video was helpful. I truly hope it was helpful. Please watch part 2. So I will see you there.